The power of one of these space rocks rises to the equivalent of 10,000 Hiroshima bombs, as the energy contained within this veritable piece of space traverses a mile across. ʻOumuamua, a puzzling object that once traveled through our nearby planetary system, has again sent shockwaves through the academic community. Elon Musk, a prominent pioneer in space technology, revealed that ʻOumuamua has returned, and this time, it is not alone in its journey. Musk asserts that its mysterious attributes contain tantalizing clues about other star systems. This is not a typical return of a celestial body, it is a reappearance that challenges our understanding of space and its true potential. Join us as we unravel the implications and secrets surrounding the alarming return of ʻOumuamua. In 1837, a mysterious object reached a surprising milestone. It crossed a distance of 1,000 astronomical units from the Sun. For over a century, this object continued its journey, quietly advancing toward our star. It wasn't until October 19, 2017, that humanity finally became aware of its presence. On that day, an image captured by the Pan-STARRS 1 telescope at the University of Hawaii revealed a faint, delicate streak moving consistently across the sky, covering about 6.2 degrees each day. This marked a historic moment, the first recorded interstellar visitor, officially designated as 1I/2017 U1, and given the name ʻOumuamua, which means scout in Hawaiian. The discovery sparked a global effort to observe ʻOumuamua through telescopes. Astronomers, including those from the SETI Institute, eagerly participated, even searching for possible extraterrestrial signals. ʻOumuamua resembled a reddish, cigar-shaped object composed of rock. Its elongated form was striking, measuring up to 1/4 mile in length and approximately 10 times longer than it was wide. ʻOumuamua's aspect ratio surpassed that of any asteroid or comet observed in our solar system. Its unusual shape was unlike anything seen before. ʻOumuamua was traveling at a speed of 196,000 miles per hour when it approached Earth, which is 85 times faster than a bullet. This meant there was no way it originated from our nearby planetary system. At first, scientists couldn't determine whether ʻOumuamua was an asteroid or a comet. Comets are made of ice, while asteroids consist of rock. Initially, it was thought to be a comet, but as it passed the Sun on September 9, 2017, scientists classified it as an asteroid. However, further measurements revealed a slight acceleration, a hallmark of a comet, leaving researchers puzzled for months. One of the key characteristics of ʻOumuamua was its periodic brightening and dimming every 7.3 hours. This dynamic behavior indicated that it was rotating around its short axis. Such a rotational pattern suggested a more rigid and durable structure than the typically fragile, snow-like material of most comets. Its appearance, dark red like some moons in the outer solar system, was influenced by space radiation. Its color could also contain iron, as suggested by Dr. Mennel, an astronomer at the University of Hawaii. Despite these insights, the origin and nature of ʻOumuamua remain a mystery. Its trajectory baffled scientists, indicating something beyond ordinary explanations. Various hypotheses emerged to explain ʻOumuamua's identity. While some believed it was a rock, others speculated that it might be composed of gas. A subset of researchers even entertained the possibility that it could be an extraterrestrial spacecraft. This raises an intriguing question: could an alien mothership be exploring our solar system, sending smaller probes to investigate planets? In the next part of this video, we will delve deeper into these mysteries. First, let's examine the range of scientific theories put forward to interpret the origin of ʻOumuamua. Dr. Mennel suggested the possibility that it could have been ejected from a distant star following a cosmic explosion or perhaps formed from the collision of two objects. Initially, astronomers were excited when they observed that its trajectory appeared to point toward Vega, the brightest star in the Lyra constellation, known to have a debris disk. Calculations showed that this object could have traveled from Vega to our region in approximately 600,000 years. However, the likelihood of Vega being the true source has diminished due to significant shifts in ʻOumuamua's direction. It is believed that ʻOumuamua may have encountered a new star system for the first time, considering its motion around the Sun, which was similar to the speed of neighboring stars. Nonetheless, there's a possibility, as suggested by nature, that Oumuamua might have been traversing near the system for billions of years. Its forthcoming trajectory remains uncertain. Imagine it this way: remember how the Voyager spacecraft gained a speed boost from Jupiter? Well, Oumuamua is similarly gaining speed from the Sun, propelling it toward a new destination. Dr. Minnell explained that this asteroid, along with its counterparts, shifts our understanding of the galaxy. When you look up at the stars, they seem distant and separate, but Oumuamua and similar objects remind us that everything is interconnected. The oxygen and iron in our blood came from a massive supernova explosion in a faraway place long ago. Shining objects like wedding rings are the result of the collision of superdense stars. Some meteorites that have fallen to Earth originated from Mars due to asteroid impacts. Remarkably, some respected scientists speculate that these meteorites may have carried life from Mars to Earth when Mars enjoyed warm and wet conditions. Life may have started there and then hitched a ride on those falling stars to Earth. It's a bold idea, but one that is being considered by respected astronomers. Our connection to the universe stretches much further back in time. Consider the millions of years Oumuamua may have taken to arrive here. While that might seem vast, it's just a brief moment on the galactic scale. The Milky Way galaxy boasts an age of 10 billion years. Over this immense time, Oumuamua could have passed through roughly 20,000 star systems, a small fraction compared to the galaxy's 200 billion stars, yet still countless cosmic journeys. Oumuamua likely gathered dust and debris along the way, allowing stars and systems to intermingle. This suggests that the universe may be smaller in scope than previously thought. Even though Oumuamua is no longer within our immediate view, our solar system hasn't forgotten it. Currently, Elon Musk and other astronomers predict that Oumuamua will enter the Kuiper belt around 2024 and cross its edge by late 2025. Musk also estimates that it will pass the farthest point of Jupiter in 2038. Although the Oort cloud is predicted to extend beyond 100,000 astronomical units, AU, by 2196, Oumuamua will still be a distance of 1,000 Australian dollars from the Sun at that time. Hence, the precise moment when Oumuamua truly leaves our planetary system depends on how one defines its boundary. Since Oumuamua has been so distant, astronomers are making the most of the data gathered during the few months it was observable to learn as much as possible about this fascinating interstellar intruder. Initially mistaken for an asteroid due to its size of around 2,600 feet in length and 260 feet in width, Oumuamua exhibited unusual behavior in its trajectory. Space experts and researchers observed an exceptional non-gravitational acceleration, indicating that forces other than gravity were at play. Past gravitational impacts were affecting its development. Dr. Minnell calculated that a few variables could prompt this speed increase. Her group analyzed 6 potential causes, eliminating some due to their unlikelihood or inconsistency with observations. One likely explanation was comet outgassing, a common event in comets. Outgassing happens when a comet approaches the Sun, and its surface ice sublimates directly from solid to gas. This process gives the comet an extra push, altering its speed and direction. Beyond gravitational influence, this change in motion resembles the behavior of comets. Notably, the absence of ejected dust from Oumuamua was intriguing. Ordinarily, as gas escapes from a comet, it carries surface dust with it. However, Dr. Minnell affirmed that even if the comet lacked fine material, the likely presence of larger dust particles on its surface could have affected its speed, keeping the possibility of it being a comet alive. Researchers primarily study visible frequencies, making it difficult to detect large dust particles. Consequently, no clear evidence of dust leaving Oumuamua was observed. The absence of gas-related signals was also surprising. Astronomers expected a noticeable amount of gas emission to impact Oumuamua's speed. Despite their efforts, no CN gas was detected within their detection limits. Considering that comets in our solar system can retain significant amounts of water, the strong upper limit set by the absence of CN gas suggested that this comet was chemically unique. According to Minnell, deducing much from what isn't known is challenging. However, it doesn't appear to behave like a standard comet. Since Oumuamua originated from another planetary system, these irregularities could be typical of objects from other star systems. The trajectory of Oumuamua was meticulously tracked back to its initial entry into our solar system by Corin Bohr-Jones from the Max Planck Institute for Astronomy. He compared this trajectory to the past positions of 7 nearby stars tracked by the Gaia satellite. Bohr-Jones rewound both Oumuamua and the star's orbits to identify potential points of intersection. Stars whose trajectories passed sufficiently close to Oumuamua's rewinded path stood out as potential origins. Elon Musk claimed that Oumuamua's trajectory crossed within a range of 1 to 2 Oort cloud radii, or about 100,000 to 200,000 astronomical units, AU. However, complications arose, as the encounter velocities of these candidate stars were relatively high, ranging from around 6 to 16 kilometers per second. A possible explanation is that Oumuamua might be a planetesimal, a building block ejected during the formation of planets. It is rare for planetesimals to achieve such high ejection speeds solely through interactions with large planets. Normally, one would expect speeds of only a few miles per second. While these speeds are high, they are certainly possible, though unlikely. This scenario becomes more plausible if Oumuamua originated in a binary star system. However, the candidate stars were not conclusively recognized as binaries. Upcoming data releases from the Gaia mission could help astronomers pinpoint a more likely origin for Oumuamua by providing further insights into the movements of nearby stars over the coming years. Returning to this is intriguing. Oumuamua remains the first and, so far, only known interstellar visitor we've observed crossing our solar system. Despite its mysterious nature, scientists worldwide are captivated by its potential and secrets. Without a doubt, Oumuamua continues to fascinate due to its unique characteristics. However, it seems Oumuamua isn't alone. On August 30, 2019, Gennady Borisov, an amateur astronomer at the Margot Observatory in Crimea, discovered another comet named 2I/Borisov. This comet was hurtling through space at a staggering speed of 93,000 miles per hour, faster than one would expect for an object around 2 astronomical units away from the Sun. What caught our attention, apart from its speed, was its trajectory. It was plunging into the solar system at an angle of 40 degrees relative to the ecliptic plane on an orbit marked by a high eccentricity of 3.7. This indicated that, like Oumuamua, Borisov had an interstellar origin. Unlike Oumuamua, Borisov exhibited a clear comet-like appearance, making it a reddish Voyager that aligns more closely with our traditional understanding of comets in the solar system. This contrast highlights the diversity of interstellar objects. Such differences are valuable for astronomers as they strive to understand the processes shaping other planetary systems, whether similar to or distinct from our own. This ongoing exploration broadens our perspective on the broader universe. Meanwhile, some astronomers have proposed that Oumuamua might be of extraterrestrial origin, further adding to the intrigue. A draft paper by a Harvard researcher and the head of the Pentagon's UFO office suggested the possibility of an extraterrestrial mothership within our solar system, deploying tiny probes like dandelion seeds to explore planets. This document was brought to light by Sean M. Kirkpatrick, the head of the Pentagon's All-Domain Anomaly Resolution Office, AARO, established in July 2022 by the Department of Defense to identify and investigate anomalous objects. Collaborating on this draft with the DoD was Avi Loeb, an astronomer at Harvard University. However, it's important to note that the paper is not an official Pentagon document. Loeb is well known for his research on Oumuamua, having previously proposed that Oumuamua might be an extraterrestrial spacecraft. 6 months before Oumuamua's closest approach to Earth, a small interstellar meteor, approximately 3 meters in diameter, struck our planet. While unrelated to Oumuamua, this meteor, known as 1I/2022 C1, captured Loeb's attention. He considered the possibility that an artificial interstellar object could act as a parent craft, releasing multiple small probes during its passage near Earth, a concept similar to NASA's space missions. In their draft study, Loeb and Kirkpatrick speculated on such possibilities. Patrick dove into unidentified flying quirks, UAPs, a term liked by the public authority for UFOs. While sticking to laid-out physics, the researchers hypothesized that the dandelion seed tests could venture out to Earth for observation without being perceivable by survey telescopes, likely due to their small size. According to their proposition, the technology of these tests could enable them to slow down an Earth's atmosphere to prevent catching fire, then use their parachute-like components to navigate to their intended objectives after landing. This scientific theory suggests extraterrestrial civilizations may seek to focus on rocky planets with atmospheres within our planetary system. Planets like Venus, Earth, and Mars would undoubtedly pique their interest, especially after identifying signs of liquid water. The mothership wouldn't necessarily have to be home to the advanced extraterrestrial civilization that created the tests. The plausibility of the mothership communicating with these tests is questionable. The idea that an intelligent planet with life could have dispatched tests long before Earth existed is an intriguing proposition. Curve compares this to periodically checking our mailbox for accumulated packages, even if the senders are no longer around. Curve has faced skepticism from the scientific community since he first proposed the idea that ʻOumuamua could be an extraterrestrial spacecraft. Some critics view his hypothesis as provocative and lacking a solid foundation. In 2021, a letter published in Cosmology and Astronomy invalidated the feasibility of interstellar travel, citing the cosmological timescales required to cross between stars. The authors concluded that it is unlikely that ʻOumuamua was sent by an extraterrestrial civilization, more reasonably attributing it to a strangely shaped rock that happened to wander into our planetary system. Another study has indeed debunked the idea that ʻOumuamua's puzzling movements could be attributed to an extraterrestrial spaceship. Instead, it offers a plausible explanation, proposing hydrogen off-gassing, which occurred on March 22, 2023, as the likely cause behind its erratic behavior. However, recent times have seen the Pentagon renewing its focus on investigating strange flying phenomena within American airspace. Since last summer, the Anomaly Resolution Office, ARO, has initiated more than 360 additional investigations into reported encounters with unidentified airborne phenomena, UAPs, by U.S. military personnel. About half of these cases have been attributed to balloons or similar objects, while the remaining half lack sufficient data for a definitive determination. In the quest for understanding, figures like Elon Musk hold hope that advanced telescopic surveys could reveal more extraterrestrial objects. These discoveries could provide valuable opportunities for scientists to put their hypotheses to the test. The parallels with exoplanet discovery offer an encouraging precedent for such efforts. Only a few decades ago, the first exoplanets beyond our nearby planetary group were discovered. In just 20 years, our understanding has expanded significantly, confirming the existence of more than 4,500 exoplanets. This progress highlights the rapid advancement in the field of astronomical research.